Welcome back, everybody. We're still going to be looking at solving equations, although we got to take a break from that yesterday. We were looking more at the solutions, but we're solving equations in a fashion that in one of the ways that we solve quadratics, but what we're solving today aren't actually going to be quadratic equations. They're what we call quadratic-like or quadratic-type equations, where the properties mirror what we see in quadratics. So what does it mean to be a quadratic-like equation? Well, what are properties of a quadratic equation? So for example, here is a pretty typical quadratic equation that we might want to solve, right? Now, if we're looking at that quadratic equation, we're looking at three terms that are set equal to 0. That's like the standard form, right? We have that ax squared plus bx plus c equal to 0. And for the quadratic-like or quadratic type that we're trying to solve, we want that same kind of feel, right? We want three terms, we want them to be set equal to 0. And then all of these below, these are all examples of these quadratic-like equations. All of the ones below here, all of these, they can be solved in exactly the same way as this one quadratic that it resembles. Now, when I say it resembles, what am I talking about? Well, just like the first one, we've got three terms set equal to 0. Okay, now notice, the leading coefficient in all of these is the same. All of these have this leading coefficient of 1. The middle coefficient, so A is the same in all. The middle coefficient, B, it's a 4, 4, 4, 4, 4, 4. Middle coefficient doesn't change in any of these problems. And then the constant, right, 3, 3, 3, 3, 3, 3, 3, didn't change anywhere. So all of the leading coefficients are the same, all of the middle coefficients are the same, and all of the constants are the same. The only thing that changes is the variables. So instead of 2 here and 1 here, we've got 4 and 2, we've got 6 and 3, we've got -2 and -1, we've got 1 and a half, 2/3 and a third, 2 and 1 again, okay? So we want that to be true in any of these quadratic likes. We want those properties to hold, where we've got the three terms equal to 0. The third term is a constant in every single one, and it's the same constant, right? And then what's going on here with our variables? Let me erase this madness that I've scribbled with dots everywhere onto our little box. So what's going on with the exponents? Right here we have an exponent of 2, and then here an exponent of 1. And then we've got 4 and 2, or 6 and 3, or -2 and -1. Can you see the connection between the exponents? And it continues even with the fractions. Well, the exponent that's on the first variable is twice the one that's in the middle. So 2 is 2 times 1, or the 2 times 2 would make 4, 3 times 2 would make 6, -1 times 2 would make -2, a half times 2 would be 1, a third times 2 would be 2/3. So the exponent on the first variable is twice the exponent on the second variable. So if that's true, right, if we've got three terms equal to 0, if the third term is a constant, and if the first exponent is twice the one that's in the middle, or the one in the middle is half the one that we have first, then we have a quadratic-like equation, and we can solve it the same way we would solve its corresponding actual quadratic equation. Okay, so how is that going to work? Might seem a little tricky at first, but I think after you do it a few times, you'll be okay with it. But I want to show you how it works on the scratch paper. What we're using is a process called substitution, okay? Let's just pretend that we were solving, or attempting to solve, x to the 4th minus 8x squared plus 12 equal to 0. So we want to try to solve this the way we would solve a quadratic, but we have to establish that it's quadratic-like first. So does it meet the criteria? Well, we have three terms equal to 0. The third term is a constant, and the first exponent here is twice the one we have here. So we're in good shape. It is a quadratic-like equation. So what we want to do, again, is a process called substitution. We want to get rid of the pieces of this equation that make this odd for us, right? The coefficient of 1 here, that's not an issue. The coefficient of -8 is not an issue, and the constant of 12 is not an issue. It's the fact that the variables are not what we're used to seeing. So what we're going to do is we're going to substitute in something else. Instead of an x to the 4th, we're going to make that an a squared, and instead of an x to the 2nd, we're going to make that an a to the 1st. So instead of x's, I'm going to use a's. and I'm going to replace the variables with quadratic, okay? So I have an a squared and an a to the first instead of an x squared, or an x to the fourth and an x squared, where it's the same property. This exponent is twice this one, but we're going to be able to solve now. Now, I don't want to change my coefficients. I don't want to change my constant or the fact that it's equal to 0, but what I want is the comparable quadratic, right? If this was a quadratic equation with the same coefficients and constant, what would it look like? Okay, so this is what it would look like. X to the fourth becomes an a squared, and x squared becomes an a to the first. All right, hopefully you're with me so far. Now I want to do this. I want to substitute these variables out and make this a quadratic because I know how to solve this quadratic. This quadratic happens to be factorable. The factors of positive 12 that make negative 8 would be negative 6 and negative 2, and dividing by 1 is not going to change those. So this is going to factor into an a minus 6 and an a minus 2, which means we get a equals 6 as a solution and a equals 2 as a solution. Okay, now we're part way there. If we were solving for a, we'd be in good shape. But remember, what we're trying to do is we're trying to solve for this original equation. We're trying to solve for x, right? So here's where we got to go back to our substitution. What we said in this substitution was that x to the fourth, right, the x to the fourth here was being replaced by a squared, okay? Now that's kind of helpful, but not really what we need. What we did was we solved for a, right? We solved for a to the first. Now a to the first, that's here. What did that replace in our original equation? Well, it replaced a squared. So if we solved for a, but a replaced x squared, if a is equal to x squared, then here we're going to put that back in, right? If a replaced x squared, now we're going to replace a with x squared, right? So x squared equals 6 here, and x squared equals 2 here, okay? And now we have two equations we can use to solve for x. If we square root both sides here, we get x equal to plus or minus radical 6. If we square root both sides here, x is equal to plus or minus radical 2. And now we have 4 solutions. Now it should make sense that we were looking for 4 solutions because we had our x to the fourth equation. Okay, so it's a process of substitution, and every time we do this process, we're going to take whatever our variables are and we're going to replace them with a squared and a to the first. It doesn't matter what they are. So if our equation was, instead of x to the fourth and 8x squared plus 12 equals 0, let's say it was x to the sixth and 8x cubed plus 12 equals 0. All the variety I showed you on the note sheet, doesn't matter what these variables are, we're going to replace them with a squared and a. And we're not going to change the constants, right? So that are the coefficients. That would stay, that would stay. Not going to change the constant. Okay, that way we have a quadratic that we can solve. Now once we solve the quadratic, we're going to end with solutions for a. And a, right, a that we have here is always going to be replacing this middle variable. So once we solve for a, we're going to replace a with what it replaced, which is our middle variable, and that's where we're going to be able to solve. Okay, so what we're doing here is we're rewriting the equation as a quadratic by replacing, substituting, however you want to say that to yourself. We're replacing or substituting the first variable with a squared and the second variable with a, or a to the first. Every single time, doesn't matter what those variables are, we're going to replace them with a squared and a so that we can make it a quadratic, because we know how to solve the quadratic. And again, the coefficients and the constants are not going to change. They will not change. And then the new quadratic that we've written, we're going to solve by factoring. And I know there are other ways to solve quadratics, but with these quadratic types, we're only going to be dealing with factorable equations, so that's good. And then once we've solved by factoring, what we've solved for is a. So we have to go back and replace a with what a replaced, and that will always be the original middle variable. So we're going to go after we solve for a and replace a with what it replaced, and it's replacing always the original middle variable. And then that will allow us to solve for x. Okay, and then just as a, something to look out for so you know a direction you're headed when you're solving. Look at the degree of your equation so you know how many solutions you're looking for, right? Like this equation, I know I'm looking for 4 solutions. Or this equation, I know I'm looking for 1 solution. Okay, so you have a little direction before you start. All right, let's give this a shot. So here we go. This is a quadratic-like equation. We have 3 terms equal to 0. Third term is a constant. First exponent is twice the one in the middle, so we're good. So the first thing we're going to do is rewrite this as a quadratic, where we're going to replace the first variable and the second variable with an a squared and an a. So I'm not going to change the 1 or the negative 17 or the positive 16. Okay? So this becomes 1a squared minus 17a plus 16. Okay, so I'm just rewriting it as a quadratic by replacing the first variable with a squared and then the second variable with a to the first. Okay, every time. Don't change the coefficients, don't change the constant. Now we have a quadratic that we can solve, and we're going to be able to solve by factoring. The factors of 16 that make negative 17 would be negative 16, negative 1. So this is going to factor into a minus 16 and a minus 1, which means one of our solutions for a is 16, and then our other solution for a is 1. Now if we were solving for a, we'd be done, but we're not. We're solving for x. So at this point, we got to go back to substitution, back to replacing a with what a replaced. Now remember, a to the first time we introduced it was right here, and that a replaced x squared. So if a replaced x squared, then now we're going to replace a with x squared. Okay, so replace a with what it replaced. So instead of a, we're going to put back in x squared equals 16, and instead of a equals 1, x squared equals 1. And now we can take the square root to solve. Square root here. That means x is going to be equal to plus or minus 4. And then square root here, leaving us x equal to plus or minus 1. 4 solutions makes sense. Our equation had a degree of 4. Okay, hopefully you're taking all this in. Feel free to pause it, take a deep breath, watch it again if you need to. I'm going to keep rolling here. So sometimes the fractions could look a little intimidating, although we know that fraction of 1/2, I'm hoping. In any case, doesn't matter. If we have 3 terms equal to 0, third term's a constant, and the first exponent is twice the one in the middle, which we have here, we can solve this just like it's related quadratic. So I'm going to rewrite this, not going to change the 1 or the 3 or the negative 40. Okay, just replacing these variables. Instead of an x to the first and an x to the 1/2, I'm going to put in an a squared and an a to the first. Okay, every single time. So this is going to be 1a squared plus 3a to the first minus 40 equals 0. All right, and this is factorable. Again, factors of negative 40 to make 3 are going to be negative 8, positive 5. So this is going to factor into a minus 8 and a plus 5, which means a has to equal 8 and a has to equal negative 5. Again, if we were solving for a, we'd be done, but we're not. We're solving for x. So now I have to replace a with what a replaced. So a, the first time we introduced it right there, it replaced x to the 1/2. So now I want to replace a with x to the 1/2. So x to the 1/2 equals 8, and x to the, oops, can't write, x to the 1/2, oh my gosh, specs of writing, x to the 1/2 equals negative 5. Now we have to remember, if we didn't at the beginning here, what that x to the 1/2 really means. What does x to the 1/2 really mean? Remember, it means the square root of x to the first. So this is really the square root of x equals 8, and this is really the square root of x equals negative 5. So how do we get rid of a square root? Well, that's the opposite of what we did over here, right? We undid a square with a square root, so now we'll undo a square root with a square. So if I square both sides here, x has to equal 64. And then if I square both sides here, I'm going to get an extraneous solution. I can square this side and square this side, but if I plug 25 back in here, right, is the square root of 25 going to get me this negative 5? No. Now remember, square roots can't be negative, so this is not going to produce a solution. This is extraneous. So we're not going to count it. All we're going to keep is this x equals 64. Now that should make sense that we only got one solution, again, because the degree of our original equation was an x to the first. Okay? So there it is. 2 down. Let's try another. Again, feel free to pause and rewatch. Now this is a real mess, and your instinct might be telling you to FOIL this stuff out, like multiply out x squared minus 2 by itself, distribute the 12, but that's really not what we want to do. This is one term, here's a second term, here's a third term equal to 0, right? Our third term is a constant, and our first exponent is twice our second exponent. So this is a quadratic-like equation. So we can solve this just like we solved the other two. But we're going to take this whole thing here and this whole thing here and replace with a squared and a. Don't change this 12, don't change the 1, don't change the 20. Okay? So this becomes, crap everywhere here, this becomes 1a squared minus 12a plus 20 equals 0. And we can factor. Okay, what are the factors of 20 that make negative 12? Negative 10, negative 2. So if this factors into a minus 10 and a minus 2, then we know that a has to equal 10 and a has to equal 2. Now if we were solving for a, we'd be good, but we're not. We're solving for x. Now remember, a that we solved for was in the middle here, and it replaced this original middle piece here. It replaced x squared minus 2. So now I want to replace a with x squared minus 2. So instead of a equals 10, x squared minus 2 equals 10. And the same thing here, x squared minus 2 equals 2. And now I can solve for x. If I add 2 to both sides, then I have x squared equal to 12. And now I can square root both sides. So we have x equal to plus or minus. When we go to break down the 12, 12 is 2 times 6, which means we're going to be able to take out a 2. So plus or minus 2, radical 3. And then here, same process. Let me add 2 to both sides, which gives me x squared equal to 4. This is just a little nicer because 4 is a perfect square. So we end up here with x equals plus or minus 2. And so we've got 4 solutions, which hopefully made sense here. If I square this square, that's going to give me a degree of 4 for this equation. Okay, so 4 solutions. And if you wanted to check any of those, you're going to plug them in. It's going to make those equations true. Okay? All right, one for you to try. Again, if you want to pause it, give it a shot. If not, here we go. We're going to rewrite this. Not going to change the 1 or the negative 2 or the negative 8. Just getting rid of this and this, making it an a squared and making it an a. Okay? So how is this going to look? So we're going to have a 1 in front of a squared, a minus 2 in front of a, and then minus 8. Now we can factor. Factors of negative 8 that make negative 2 would be negative 4 and 2. So this becomes a minus 4 and a plus 2. So that means a is going to equal 4 and a is going to equal negative 2. So if we were solving for a, we'd be done, but remember, we're not. We want to plug x back in to this situation. So a replaced x to the 1/3. So now it's time to replace a with x to the 1/3. So x to the 1/3 equals 4, and x to the 1/3 equals negative 2. And now, if you remember, just like with the square root, x to the 1/3 is the same thing as the cube root of x to the first. So if you want to rewrite this as the cube root of x to the first, you can. But in either case, if you want to get rid of a 1/3 power or a cube root, what are you doing? Well, you got to cube both sides. So this is going to give me x equals 64. And then I'm gonna cube both sides here. Remember, no restrictions for cubes, cube roots. They can be negative. So this one is gonna give me x equals a negative 8 as a second solution. So a second solution. Now, it's not as obvious that this equation should have 2 solutions, but if you think about this, this was a cube root of x squared. that x squared in the equation is why this equation can have two solutions, okay? So there they are. All right, moving right along. I think I just have a little more variety for you on the back. A little stretch break might be necessary. Luckily, you get to pause. All right, so here, rewriting this as 9a squared minus 38a and then plus 8 equals 0. Didn't change the coefficient or constants, just the variables. We can factor 9 times 8, 72. Factors that make 38. Let's see. How we're going to get a 38 out of that. Oh, 2 goes into 72 36 times. Let's make those both negative. Now remember, when our leading coefficient isn't a 1, we have to divide. So this is going to factor into 9a minus 2 and a minus 4 equal to 0. So that means a is going to equal 2/9 and a is going to equal positive 4. And now we're going to replace a with what a replaced. So I'm going to put x squared in here equal to 2/9 and x squared equal to 4. I'm going to square root to solve. So x is equal to plus or minus. I cannot square root the 2, but I can square root the 9, so that becomes a 3. And then the same thing is going to happen here. Square root. So x is going to equal plus or minus the square root of 4 is going to give me a 2. And there are the 4 solutions that I knew I was looking for. Okay? So all pretty straightforward so far. I think sometimes these negatives are a little tricky, so let me show you how to handle this guy. If you want to give it a shot, you absolutely can. So we're going to make this 1a squared plus 3a to the first plus 2. Make it a quadratic. Factors of 2 that make 3 are 2 and 1. So this is going to factor into a plus 2, a plus 1, which means a is going to equal negative 2, and a is going to equal negative 1. Now a is going to have to be replaced. We're going to replace a with x to the negative 1. So this is x to the negative 1 equals negative 2, and x to the negative 1 equals negative 1. So now the question is, how do we solve that? Right? How do we get rid of x to the negative first? All right, let me go to my scratch for a second here to show you. There's 2 ways you can think about this. So x to the negative 1 equals, what was it? I forgot. Let's say it was 2. I think it was 2. How do we solve this? Well, if you remember what a negative exponent means, it means that the base of the exponent is on the wrong side of the fraction. So x to the negative 1 is really the same as 1 over x to the positive 1, and then I still have a 2 on this side. Well, if I make the 2 that's on this side a fraction, then now I have a proportion, and I can solve by cross multiplying. So 2x has to equal 1, which means x has to equal 1/2, right? So that's one way to approach this. Or the other way to approach this, we have x to the negative 1/2 equal to 2. It's kind of similar with the cube root of x, okay? Cube root of x, we said get rid of cube root, we would cube. Or if I left it as 1/3 here, if I cubed that, the 3 and the 1/3 would make the power of 1, right? That's what we want. We want this x to have a power of 1. So I could just raise both sides to the negative first, right? And then the negative and negative here would cancel and give me a positive 1. That was the goal. And then on this side, 2 to the negative 1 is 1 over 2 to the positive 1. So same answer. I think this way is a much easier way to get there. It's just kind of whatever your brain is seeing. So I'm going to do one of each on the other side, and then you can kind of choose. Okay? So here, let me do the cross multiply approach. We could say that this is 1 over x to the positive 1 equal to negative 2. And the negative 2, I could make a fraction by putting a 1 under it. Then I could cross multiply and say negative 2x equals 1. And then I could divide and say x equals a negative 1/2, right? Or if I wanted to, I could just raise both sides to the negative first. So a negative would cancel and give me x to the positive 1, which is what I want. And then negative 1 to the negative first means 1 over negative 1 to the positive first. But in any case, that's going to be a negative 1. Okay, so we have a negative 1 as a solution and negative 1/2 as a solution. And again, this isn't one where it's obvious to see that we should have two solutions, but if you think about this originally is 1 over x squared. And that x squared in the equation is why this thing can have two solutions. Okay? So I got another fun one here with some fractions. These tend to make people hesitate a little bit, but same process. So I'm going to have 1a squared minus 5a plus 4. I'm going to find the factors of 4 that make -5. So this thing factors into a minus 4, a minus 1. And that means a has to equal 4 and a has to equal 1. Now I'm going to replace a with what a replaced, that original middle variable. So this becomes x to the 2/3 equals 4, and x to the 2/3 equals 1. Okay, so a couple of ways to look at this. Again, you can raise both sides to the 3/2. Let's take that approach here. Let's see. Let me go back to my scratch. So you have something to the, crap, I forgot. 2/3 power. How do we get rid of the 2/3 power? So I want this exponent to be a 1 here. I could raise both sides to the 3/2. Raise both sides to the 3/2. But we got to be careful here because we might miss a solution. So this says if I didn't want to raise it or solve it this way, if I have x to the 2/3 power equal to 4. Remember, this is the cube root of x squared equal to 4. So I could cube both sides, right? Get rid of that cube root by cubing both sides. That's going to leave me an x squared equal to 64. And now I have to square root both sides. And I square root both sides, and I have to put in a plus or minus in front of my 8. So two solutions I'm looking for there. Whereas if I had done this the other way, well, I had it here. If I had done this the other way, these will cancel and give me x to the 1st. And then 4 to the 3/2 is the square root of 4, which is 2. And then 2 cubed, which is going to be 8, the one solution. Unless here, right, square root of 4 is technically plus or minus 2. And then when we cube that, we get plus or minus 8. I just think it's easier to lose the plus or minus in the process here. Normally when we square root a number, if I was just evaluating 4 to the 3/2, I wouldn't put the plus or minus in here. But remember, we're solving, and when we take the square root in the solving process, that plus or minus has to go in, okay? So I'll do both here, again, so you can see the variety. I can make this the cube root of x squared equal to 4, and then I would cube both sides, make this x squared equals 60, oops, go back to red here. Make this x squared equal to 64, and then I would square root both sides, and so x is going to equal plus or minus 8. And then the other option is to raise both sides to the 3/2 power. So then I would have x to the 1st here, and then I would have the square root of 1, which is plus or minus 1, and then I have to cube that, and so I get, well, 1 cubed is 1, and -1 cubed is -1, so I still get plus or minus 1. So I get 2 solutions here, and 2 more solutions here. Again, not obvious, but this is a cube, this equation, right, to start is a cube root of x to the 4th, and that is why this equation is going to have 4 solutions, okay? It's probably about as tricky as it can be. I got one more here if you want to give it a shot. Feel free to pause. Otherwise, 1a squared plus 9a plus 8 equals 0. Factors of 8 that make 9 are 8 and 1. So if this thing factors into a minus 8, plus 8, a plus 1 equal to 0, then a is going to equal a -8, and a is going to equal a -1. All right, now we're going to replace a with what it replaced. So this becomes x cubed equals -8, and x cubed equals -1. And now to get rid of the cube. Get rid of the cube, we take the cube root of both sides, and so x, oh my goodness, trying to color coordinate. This makes x equal, cube root of negative 8 is going to be a negative 2. And then if we cube root here, cube root this side, cube root this side, we get x equal to negative 1. 2 solutions. Gosh, I could make this so much more complicated. This can have 6 solutions. The other 4 solutions are in there. I'm not at a point where I can explain where those solutions are going to come from quite yet. When we move on to our polynomial unit, we'll be able to figure out where the rest of those 4 are. For now, let's just leave it here, just because we're not quite prepared for that step yet. I might have chosen a different example, but the process I want you to be comfortable with is this process of substituting and then substituting back, okay? So getting rid of the variables to make it quadratic and then going back. So we got 2 of the 6 solutions. The other 4 we'll be able to find eventually. For now,